In this last example, we'll take the example from the previous video and we'll actually make a slight change to it. We'll actually look at the probability that the mean price of a random sample where n is equal to 32 is less than $15. So in this case, we have a right skewed distribution of stocks, which we saw in the last example. And our facts are that we know that the mean of that population is 26, and we know that the standard deviation of that population is 20. And we know that our sample size is 32. Now the sample size is very important because the sample size actually dictates whether or not we can do any more with this information. A sample size of less than 30 is not going to yield anything that approximates a normal curve. So if our sample size is greater than 30, it's been proven that sample size greater than 30 will actually yield something approximately close to a normal curve if you look at the mean price or the mean of that random sample that you're taking. Now this talks to the law of large numbers, and 30 just tends to be the magic number that we're looking for here. So as you can see, we have three pieces of information. We've drawn our normal curve, and now we need to figure out what the standard deviation here is. Now we know the rule states that the mean of the curve, of the normalized curve, is equal to the mean of the population, regardless of whether it is skewed or normal. So the mean of this population was 26. So we'll put that right there in the center. So there's our mean. Now, the standard deviation of the population is definitely going to be different in a skewed distribution. Well, it's going to be different regardless. So we need to actually compute that standard deviation. But now that we know the population size, or the sample size, we can actually go in and calculate that. And if you recall that the standard deviation will be the population standard deviation divided by the square root of the sample size that we're working with. In this case, we're talking about 20 over the square root of, and we have 32 as our square root. Now if you do the math on that, you should get 3.54. So now we have the standard deviation of the random sample, the mean price of the random sample. So the next thing we need to do is figure out what the z-score is, because again, we're being asked about the probability that the mean price is less than 15. So let's look at that on the chart. So less than 15 would probably put us somewhere down here. So we are looking for everything that is to the left of this, because it is less than 15, and we know that the prices are increasing as we move to the right. So we're looking for everything to the left of this 15. So what that tells us is whatever z-score we find in the table of standard normal probabilities, that will be our answer. So we are looking for P, the probability that x bar will be greater than 15. Now we already calculated the standard deviation, so the next step of this is to calculate the z-score. The z-score is x bar, or the mean minus mu, over what we just calculated, standard deviation of the population divided by the square root of the sample size. And if you plug the numbers in, you should get 15 minus 26 over 20 divided by the square root of 32. And this number should come out to be negative 3.11. If I look that negative 3.11 up on the table, I should get 0.0009. And what that tells me is that the probability that x bar is greater than 15, or the probability that the z-score, so the x bar is less than 15, I should have said less than here, my apologies, less than 15, or the probability that the z-score is less than negative 3.11, which is the number we got back here for the z-score. This, we figured out, is equal to 0.0009. So essentially what that tells us is that there's less than 0.1% chance of this stock being less than $15. So we just do the math, 0.09% chance. Of the stock being less than $15. Now I made a mistake here. The mistake I made was that I said the chance of the stock being less than $15. That's not actually true. What we're talking about is the mean price. Price of the sample being less than $15. Big difference.